Okay, tonight I'm very happy to introduce our speaker, Michael Kauffmann, who is a man of many talents and many interests. He's an educator, an author, and an ecologist. He founded Backcountry Press, and he's written several books: Conifer Country, Conifers of the Pacific Slope, California Desert Plants, which he's going to tell us about tonight, a Field Guide to Manzanitas, and a book that just came out, I believe it was last year, The Klamath Mountains and Natural History, which has gone over very well in the publishing industry. So please join me in welcoming Michael Kauffmann.
Here. So this story that I'm about to tell came out of, and I need to go back a slide because I need to acknowledge Phil. But Phil Rendell is an emeritus at UCLA, and he is one of the world desert experts. And Phil approached me with this book about 3 years ago, and he's been working on it since the early 90s. And basically, he designed this book around his lectures that he gave in various desert classes. And so we put this together with Robert Gustafson. Phil did other books on Southern California, flora, and Robert is the photographer, one of the lead photographers in those books. But it's just so easy now to get great photos on iNaturalist. So we really dug down deep and asked Matt Berger. Matt Berger actually contributed 1/4 of the photos in this book. He's such a, he's always out there. If you don't follow him on social media, he's got some great pictures. But all these other folks came together to help contribute images. And here's the general table of contents. And basically, what I'm going to do tonight is tell some of the stories that Phil basically has told in this book, through my perspective, and weaving in some stories that I find particularly fascinating about California desert plants. So, desert ecosystems around the world. There's really no simple, all-encompassing definition of what constitutes a desert. But geographers typically define a desert as a region that receives less than 10 inches of rain a year. But this rainfall limit is somewhat arbitrary, right? There might be 2 inches one year and 14 inches another, but obviously that comes down to the average part. But even places like the Creosote Plains in California would fit this desert definition. But yet that area might receive a little bit more, say, foggy days or more overcast days, right? So that might rule it out from other people's definition. So we're going to kind of explore the deserts of California as defined by geographers and not necessarily including in the Creosote Plains. And here are the deserts of North America. You can see the Great Basin is in blue in the north. The Mojave is this area. I actually think I can, let me put a laser pointer. I think this will work. The Mojave is this area here in the central. It's about 3/4 of which is in California. Here's the Sonoran. We often refer to this little corner of the Sonoran as the Colorado. I'll get into a little more details about that in a minute. And then here's the Chihuahuan desert. So let's start with the Mojave. The Mojave is sort of this meeting ground in the middle of both the Sonoran and the Great Basin. It's the smallest of the 4 North American deserts at roughly 48,000 square miles, which is roughly the size of New York. And 75% lies in California, but it does extend beyond the borders into southern Utah, northwest Arizona, and parts of Nevada. And this is a great fact. I was just at the Desert Research Center at the Granite Mountains, and Jim Andre, who went to Cal Poly up here, told me that if the Mojave was a state, it would be the 8th most diverse in terms of plants. So pretty amazing to think that this desert region, we think deserts are not diverse. That is not true. The Mojave Desert is really a transition, though, between the higher and cooler Great Basin and to the north, and then the lower elevation Sonoran Desert to the south. And the elevations of the Mojave are generally between 2,000 and 3,000 feet, but there's a lot of variation there that I'll talk about, with Telescope Peak, for instance. And then by comparison, the Great Basin valleys are typically around 4,000 feet. So when I said 2,000 to 3,000 feet, that's the valleys of the Mojave. And the Sonoran Desert generally has valley elevations of around 1,300 feet on average. This is a picture of Saline Valley. There's quite a few mountain ranges that are named across both the Mojave and the Sonoran in California. And if we go, some of the more famous ones are here's the Kingston Range and the Clark Mountains. These are both above or close to 8,000 feet. The New Yorks reach about 8,000 feet. And then things start to drop off as you get further south to around 5,000 feet in that transition zone into the Sonoran Desert. Here's a nice view. This is from the Granite Mountains looking south towards the Old Woman's and some other mountain ranges. But this is really that transition where you're dropping out of that higher elevation Mojave and into that southern, the lower elevations of the Sonoran. So what is the Sonoran? The Sonoran in California forms a relatively small portion of the whole entirety of the Sonoran Desert, which extends across southwestern United States, as we saw on the map. The California portion is distinguished because of the winter rainfall regime, though. That's when the rains come in the California version of the Sonoran, and that's why I think this different term, the Colorado, has sort of emerged over time, because it is somewhat different than the rest of the Sonoran. But there's still characteristic plants of the Sonoran that are in the California part of the desert, like Ocotillo. And the Sonoran in California does not typically get that biseasonal rainfall regime of the Sonoran Desert of Arizona with the monsoons. And there are obvious exceptions to that, but you know, particularly this summer with Hurricane Hillary that came through, right, and dropped. Of course, that's not a monsoon, but dropped 4 inches in the summer. And so the Great Basin is a cold desert. And this is a map of sort of the entirety of what the Great Basin is. But the Great Basin is interesting because it's obviously an area that doesn't drain. It has these large lake basins and small rivers that move from basin to basin. But the annual precipitation here is between 7 and 12 inches a year, and that's largely as winter snow, but it also falls as thunderstorms in the summer, isolated thunderstorms. And this low rainfall is not sufficient to produce major rivers, but instead it creates what's called an endorheic or internal catch system. And it was once home to large lakes in the Pleistocene, like Lake Bonneville around the Great Salt Lake. Here's a picture of the Great Basin where 299 turns to a dirt road at the Nevada border. There's actually petrified redwoods close by to this picture, but this one of the ecological factors here in the areas of the Great Basin are these characteristic plant communities, particular sagebrush steppe, sage scale scrub, and then the pinyon juniper woodlands. And I'll talk about those at the end. Climate regimes. California deserts are characterized by a Mediterranean type climate, which is distinct from other desert climates in North America. And although the rainfall is highly variable from year to year across California's deserts, it's most common in December, and then with the occasional thunderstorms. But this poses a challenge for many plants, because you think about the ability to get water now, but not grow for a couple months. So a lot of the plants in the California desert are adapted differently than plants in other deserts around the world. I took this picture. I just went to the desert, and we got out of Vegas as fast as we could. But I think what's interesting about Las Vegas, when we think about the deserts of California, particularly the Mojave, is when really right along south of Vegas, right along the Colorado River, that is sort of that borderline between the summer rainfall, the biseasonal rainfall, which happens to the east, and then the winter rainfall regime, which only happens west of there. So there's kind of this interesting divide in the plant communities that happen right there along the Colorado River, and you can think about it in terms of the saguaro cactuses. Whoops, I already showed you that. Sorry, this is the first time I've given this talk, so there's going to be a few glitches in here. So I want to talk briefly about some of the geologic diversity that drives plant communities and patterns in the deserts. And these are just some pictures to think about the vast diversity of geologic forms in the desert. So there's weathered granite. This is a classic Joshua Tree picture. There's sedimentary. This is in the Eureka Dunes area of Death Valley National Park. There's these Bajada slopes that are often dominated by creosote, which we'll talk about in a minute. There's volcanics. Silas, we went here together. This is just south of the Granite Mountains, and that transition zone into the Sonoran. There's these braided washes, and so these, we'll talk more about this in a minute, but these create novel habitat for certain plants like the smoke tree that's highlighted here. There's these desert basins that are characteristic of the Great Basin in particular, but also areas of the Mojave. There's desert dunes. This is the Kelso dunes and the creosote scrub that kind of just reaches into the edge of the dunes. Here's a little glory shot of a storm rolling in on a recent trip into the Kelso dunes. And then there's this cool phenomenon called desert pavement, which, you can see here, it really just cuts a line off where the plants can't grow, or very few plants can grow. So, all of these things are drivers of diversity and drivers of different plant communities. One of the unusual features of deserts is the remarkable diversity of plant growth forms. So anything from subshrubs to trees to geophytes to succulents. Most biomes have like a single dominant growth form, right? So we think about the redwood forest, right? Or the chaparral with evergreen shrubs. But all of these plant growth forms can be found across desert ecosystems. So diversity of forms through the seasons. If we visit the deserts over most of the months of the year, we would have a nice enumeration of diversity of woody shrubs, subshrubs, and a few trees, and a small list of succulents. However, we would be missing the great majority of that diversity. And that's the diversity that comes out when we hear about the super blooms, right? So all the woody and succulent growth forms together combine to define only about 1/4 of the plant species in the California deserts. The other 3/4 of the plant diversity occurs annuals and herbaceous perennials that either complete their life cycle and set seed before the end of the growing season or die back to the ground level with the onset of drought stress in the summer. So the largest component of the diversity of the desert is cryptic. There's other adaptations for plants, and I'm not going to go into the gory details, but maximizing rates of photosynthesis during certain times of the year, plants can do this. Leaf energy balance, so moving with the sun of the day. There's stem photosynthesis. We'll talk a little bit about that. And then there's this cool cam metabolism, this photosynthesis that plants can actually, during the day, they can shut their stomatas, and then at night, and they can photosynthesize. Then at night, they open their stomatas and they let more carbon in, and then they close it off. So this helps to save water through the heat of the day. Okay, so what I'm going to do for the rest of the talk is we're going to just go through some of the plant communities in the California deserts. We're going to talk about some specific plants, some broad level landscape things, and show you some pretty pictures. So you have to start any discussion of California deserts, or really any of the deserts of North America, with creosote bush scrub. This is the most widespread and dominant plant community across both the Mojave and Sonoran. And this community in varied forms covers perhaps 70% of the total area of both of these deserts. And it occupies a broad range of habitats and geomorphic substrates. And let me show you a few examples in a second. Creosote bush is Laurea tridentata. It's a remarkable species. It's in the family Zygophyllaceae, which is, as you might imagine, more of a subtropical tropical species. And to begin with, no other desert shrub even comes close to rivaling the ecological success of creosote bush in the California desert. Not only does it dominate broad areas, but it's also in the Chihuahuan Desert. And this success is particularly surprising when you consider the fact that it's a relatively recent immigrant from South America. Fossil evidence says about 22,000 years ago, it arrived in North America. There's 4 other species of Laurea, and they all occur in South America, in the arid areas of South America, with the range centered in the Monte deserts of Argentina. So you've got this one group that's just all of a sudden exploded in 22,000 years across the California deserts and deserts in North America. So here it is on volcanics. This is in the Turtle Mountains. Here's a nice little close-up by Matt Berger of the flowering. It's evergreen too, and this is unusual for desert shrubs in California. The vast majority are drought deciduous, which means they lose their leaves after water availability wanes. And this ability to maintain leaves through such stressful summer conditions requires these amazing adaptations. The first of which is the ability to maintain metabolic activity under extreme water stress. They have small leaves, and this is effective in allowing them to maintain leaf temperatures close to air temperatures. And then the foliage of creosote bush shows an interesting pattern where the branch clusters are arrayed facing leaves to the southeast with an inclination between 35 and 60 degrees. And this minimizes self-shading during the morning hours to optimize net photosynthesis, but and then it also decreases solar radiation over the course of the day. So anyway, pretty wild. What a cool plant. You kind of get tired of seeing it when you're in the desert, but you gotta be appreciative, you know? So the other sort of dominant feature, it's particularly of the Mojave, is the Joshua Tree woodland. And here's a nice range map of the Joshua trees, and the Joshua trees are split into two varieties. The orange variety is generally taller. This is the photo by Julie Evans here on the right. This is the western Joshua tree. And then I'll show you a picture here of the eastern Joshua tree. You can see they're a little bit shorter, a little bit less branchy, I guess, so to speak. And this is a picture from a wilderness area in Nevada, the Joshua Tree Wilderness. I'd never been there before until a couple of weeks ago. It's got a lot of the blackbrush scrub in the understory, but just a phenomenal spot. Thousands and thousands of acres of Joshua trees and pinyons and junipers, really spectacular. There's other yuccas in the desert, California desert as well. There's the Mojave yucca, Yucca shindigera, which is the most common. This is the one that I basically saw repeatedly over my last few trips, and kept thinking, oh, this one must be a banana yucca because it's short, and it never was. And then I finally saw the banana yucca, and it's much more low to the ground, even a different color, and it's got that interesting set of seed pods there that makes it distinct as well. Cactus succulent scrub. So this is a view of the Providence Mountains. If you've been to the Mojave National Preserve, you can see the mix of the barrel cactus. There's some other smaller cactus in the kind of in the buckbrush there, and then also the Mojave yucca. But we're going to talk a little bit about cacti for a few minutes because they're obviously quite charismatic. So wide variety of choyas in the desert. Some of the most, I think easier to recognize are the teddy bear choya and the branched pencil choya. There's prickly pear, the Mojave prickly pear, pancake prickly pear. I mean, the prickly pear, the Opportunia are quite diverse. California barrel cactus. Silas was quite enthused about sitting on one. But what's interesting about the barrel cactus, and somehow my notes all disappeared here, so I'm going to have to wing this one, but the barrel cactus have this similar inclination where they point themselves towards the south, and this does a couple of things. It minimizes net photosynthesis during the hot summer months, but in the spring, because the tip is where they flower, it also accelerates flower growth. So that those flowers can get out there quick, they're warm, and but before things start to get dry again. And they have a remarkable ability to store water as well. And here's a glory shot of the hedgehog cactus in the Turtle Mountains. And then I want to talk a little bit about agaves and nolinas, because when in a recent trip into the Mojave this past, well, just a couple of weeks ago, we walked up into this canyon and I got to see both simple desert agave for the first time and the Bigelow's nolina, which this is at a place called Coffin Springs, and the spring was totally dried up, but the nolina was sort of surrounding where that spring used to be. So they have this affinity for sort of these, shaded areas, north-facing aspect where, they get shade throughout the day and there might even be a little bit of moisture around. Okay, woodlands, wash woodlands and arroyos. This is, these are the places that when you go to the desert, you walk through them, right? They're just so fascinating with all of the the ability to kind of walk in these disturbed areas, but then also the ability for some of these plants to pioneer so quickly after these disturbances. Whoops. Okay, so this, here we go, blue Palo Verde. So, I talked, another adaptation that I talked about was the stem photosynthesis. And Palo Verde and smoke tree are two sort of prime examples of species that do this. So the Palo Verde is kind of weird because it will grow leaves, but they typically only last for a couple of days, maybe a week after the rainstorm, and then they lose those leaves as the water in the wash system starts to dry up. And then they maintain that photosynthesis through their stems. And one thing that's fascinating about the washes, right? You think about when rain falls, right? A lot of it is going to be channeled into these washes. And a lot of these plants have this ability to kind of help that slow that flow of water, right? And as they slow that flow with their root systems, they're able to gather that up and capture it. So really, these are keystone species for maintaining, sort of an aquifer retention system, but also for nutrient loads in these washes. We were there after Hillary, and it was like these giant debris flows had been sort of held up by the plants that, like the Palo Verde, and they slow that down and they help build those nutrients and keep them within these wash woodland systems. The smoke tree, this is in the legume family, and it's super spiny. Silas, when we saw this thing, I actually touched it and it got a little blood on my finger. I was like, oh my gosh, I didn't realize, or I'd forgotten how spiny these things are. But they do the same thing. They don't have leaves. They do stem photosynthesis. But because they're in the legume family, they also fix nitrogen, which again is another important factor for the wash woodland communities, right? The ability to fix nitrogen can help the other smoke trees, but also any of the other annuals and perennials that are growing within that system. Desert lavender. This was a super charismatic, common desert wash woodland, a beautiful smell, easy to recognize in the, actually, is it Lamiaceae? I think it is Lamiaceae family. Brittle brush. This is in sunflower family and Celia farinosa. They just have this beautiful form to them. And then just some glory shots of the wash woodland systems. You can see even some creosote is creeping into this wash woodland. Walking up towards the Mojave Springs and the Turtle Mountains. Whoops, redundant there. Sorry about that. All right, I want to get into the wetlands. And this is Mojave Springs in the Turtle Mountains, and this is the northernmost range extension of the California fan palm. And for some reason, every single one of my notes has disappeared. So anyway, fan palms are in this exceptional species, though, right? It's really kind of this if you think about the Sonoran Desert and you go to Palm Springs, everybody's like, oh, you got to visit the fan palms. And the fan palms are it's an ancient lineage. It's been around since the tertiary, so about 40 million years they've been around. And they had the fossil record showed them on coastal California, spread out all across the Mojave. I'm sure they were surrounding these lake basins that are now dry. And now they're kind of restricted to two areas. One are these steep cliffs that you see here. And this is the case because, often the water, this is the San Jacintos, right? So the water's coming off and collecting in these pockets in these steep cliffs. And then the other places you'll see them is in the low-lying valleys. And this often has to do with the geologic factor where that water is pushed back up to the top in a wash. And this is one of the most extensive fan palm groves in California, near Palm Springs. And then here's Mojave Springs, and this is the only water at Mojave Springs, is murky. Interestingly, I remember drinking out of that like 20 years ago, and I don't think it looked like that. So I wonder if things have changed. But just a spectacular sight to see that these, I think it's about 20 fan palms are still surviving at their northern range extension. But another interesting thing about fan palms is they're moved around. So there's a little bit of uncertainty about what are the native groves or what are the naturalized groves, what are the groves that have been moved around by humans in more recent time. And this is a picture of the Saline Valley Hot Springs below the Inyos. And people have brought these fan palms in here. So other desert riparian woodlands, this is the Amargosa River near Tecopa. And this will flow occasionally, right? It's because of the geologic factors. This water will, when there's enough water flowing from the Mojave River out of the San Bernardinos, this river will rise up. And so here's Tecopa. So Tecopa, yeah. So Tecopa is actually a combination of both the Amargosa and the Mojave River. And so this is a picture of ancient Pleistocene lakes across the Mojave and creeping down into the Sonoran. So you can see that there were extensive lake systems in the past. And then obviously I've shown you this picture before, but the Great Basin sort of over time since the end of the Pleistocene has really dried up and these lake beds have disappeared, except for certain times of year. And this is a picture of Saline Valley in the winter of 2008, 2009. What a spectacular reemergence of the Saline Valley Lake because of that wet winter. There's a couple other exceptional places to visit, springs and wetlands in the California deserts. This is actually just across the border in Nevada at Ash Meadows National Wildlife Refuge. Pretty famous spot for these beautiful blue pools and the desert pupfish that live within these pools. This is the best picture Allison and I could get of the pupfish back in the day when we visited. But what's, you've probably heard about the Devil's Hole pupfish, and this, it has been said that the species in the Devil's Hole, it's basically this one, hole in a granite rock face that, the Amargosa River flows underneath it, but, due to groundwater pumping has really dropped over the last 100 years, but it's one of the most restricted, if not the most restricted place that a species lives on planet Earth. I think there's 400 or 500 of these fish left. So definitely well worth a visit to the Ash Meadows. Okay, I'm going to end with sort of a strong suit of mine, Conifers of the Desert. I shouldn't need too many notes here because they've all disappeared, but it's fascinating, right? You get into the Sonoran Desert or the lower slopes of the Mojave, and those conifers are just not there. But this is on just outside of Las Vegas, up in oh God, I do need notes. What's the high peak outside of? It's not Wheeler. Charleston, thank you. This is in the Charlestons, and these are bristlecone pines. And Charleston gets up to 13,000 feet. So there, I mentioned Telescope Peak. There's some high elevation spots for conifers in the Mojave in particular, and obviously in the Great Basin as well. But before you kind of get into that conifer zone, you often start to transition with blackbrush and then also sagebrush. But what's cool about sagebrush is it has this vast amplitude. It can be down from about 2,000 or 3,000 feet all the way up to 10,000 feet across these desert systems. And one place to see that really well is in the transverse ranges on the edge of the Mojave, kind of rimming the Los Angeles basin. So I would make the argument that the Big-Cone Douglas fir is also a desert species. So the desert kind of creeps in. This is the Mojave. This is the boundary of the Mojave. And then you get down here, and here's the Sonoran. This map's a little funky because it's not oriented exactly north-south. But as you drive from San Diego on Interstate 8, you actually pass a grove of Big-Cone Douglas fir. But then here, out of the areas of Lancaster and Palmdale, they get really close to the desert. And I was fortunate enough to do some mapping of this species in the around 2015. And this is the north slopes of the San Gabriel Mountains. So here they are growing with Arctostaphylus perriana, but transitioning in, and I saw them growing with Joshua trees, but I never took a picture of it. Here's a nice other view. So Lancaster and Palmdale are just down this canyon. You can see they're also here with canyon live oak. There's even a few sugar pines right behind me that are trickling in, or trickling out, I guess I should say. And then here's the Sierra Polonas. And this is the Tehachapi Range in the background here. That you can see maybe some of the wind farms. But again, right at the edge of the Mojave, there's some black oaks. But look at the recruitment of the big cone Douglas fir. Doesn't that look a little bit similar to the oak encroachment that we see here with our Douglas fir? So interesting phenomenon at the edge of the desert. This desert conifer. It's a desert-like conifer, I should say. So the main desert conifers, though, are the pinyon junipers. And I showed you this picture before. This is from the Granite Mountains looking south, transitioning out of the Mojave into the Sonoran. Those mountains just aren't high enough out there to host the pinyon juniper. So I took that picture from this spot right here. And you can see very few places besides out in Joshua Tree National Park where it's kind of that high elevation, contiguous nature of the transverse ranges. The pinyons and junipers, they just basically disappear from this corner of the desert. Another interesting phenomenon is this Perry pine, Pinus quadrifolia, that transitions. It's basically, a new species that's forming, right? It's related, very closely related to the single leaf pinyon, but it's developing its own sort of niche and morphology as it transitions into the southern part of the California floristic province in Baja California. We also have desert junipers, including the Utah juniper and the California juniper. The California juniper, though, gets into the Central Valley. And then the Utah juniper really starts to take off as you go further east into the Great Basin and the higher elevations of the Sonoran in Arizona. Then there's the white fir pinyon woodland. And I put this map in from Cal Flora because you can see there's 1, 2, 3, 4 places basically, and then in the Charleston Range here, that you can see white fir in the California deserts. And this is not the. I just realized I did have all my notes, but I scrolled down and I couldn't see them. So anyway, I think I pulled that off. But anyway, the cool thing about the white fir in these is it really is the harbor. It just shows you where are the high elevation mountains. So here's the Kingston Range right here. Here's the Clark Mountains, and here's the New York Mountains. So those are the places above 8,000 feet. This is a photo by Duncan Bell of them actually. So Vegas is right behind this guy. This is in the Clark Mountains, and they're going up and they're doing some seed collection to, who knows what's going to happen to these trees. There's only 30 of them left in the New Yorks. I think it's about 200 in the Clarks. Maybe it's 300 in the Clarks and 150 in the Kingstons. So there's not a lot of these trees left, but yet, the genetics are being preserved, which is super important. And then lastly, we'll end with the bristlecone limber pine forests. And of course, these are sort of the real, probably the most charismatic or maybe one of the most well-known trees in the world outside of maybe redwoods, right? The bristlecone pines, longest lived single species on Earth, upwards of 5,000 years. And here's a nice picture of the cones from the Charlestons, and my friend Brandon took this great picture of the bark of the bristlecones. Here's a range map. So if we think about the subsection Balfourianae, this includes the northern foxtail pine, which we have in the Klamath, the southern foxtail pine, which we have in the southern Sierra Nevada. But then just across the Owens Valley, you get into the Great Basin bristlecones. These are in the White Mountains and the Inyos. There's a place in China Lake Weapons Naval Station where there's some bristlecones, and then Charleston, and then the Sheep Range, and then further out into Nevada. So just really isolated, 8,000 feet or more, probably 9,000 feet or more. And then even the Rocky Mountain bristlecones around Flagstaff and in the Rockies. So gotta love the bristlecones. We also have limber pine in certain areas of the desert, including the White Mountains. This is a picture from the San Gabriel Mountains. This is Mount Baldy and Mount Pinos, and then here's the smoggy Mojave and the San Bernardino, LA Basin area over here. I used to live right down in here in a little town called Wrightwood, and I know Maggie's on. So what's up, Maggie? And Maggie lived with me there, taught outdoor education with me. And here's a nice range map of, well, nice, I guess I made it, it better be nice, but you can see how they only kind of trickle into a few areas of the Mojave, and then few areas of the Sierra Nevada, and then in the transverse ranges. So pretty rare conifer in the deserts and really in California in general. Okay, so that is what I have for you. That's sort of my fast and furious story about the desert. And I really appreciate you all coming out and listening. I just want to shout out one more time to the book that we are selling it online currently, 30% off for all you Zoomosphere folks. And get out, take it out, explore. I took it with me to the desert and I was reading it every night last couple of weeks ago. Like, it's just packed with all sorts of fun information. Thanks to the lifetime work of Phil Rundle. All right, so I'll leave it at that. I might be able to answer a few questions. I might lean on Dana York if anything gets too hard. So thank you. Okay. Any questions here in live world before I get sucked into Zoom? Yes, Sebastian.
So, when you were talking about those kind of transitional zones with that sagebrush, I know that, when you were talking about the transitional zones with the sagebrush and the kind of pinyon juniper woodlands,
Yeah.
I know that in like the Southwest Desert in the US and as well in the Great Basin, like conifer encroachment in those environments is kind of not necessarily posing a threat, but it's definitely having larger impacts with sage grouse, with other kind of smaller endemics that don't deal with shade as well or getting out competed. In your time since you've been going out there, have you seen a lot of changes? I know that it's obviously a little different with deserts and that low precipitation and how that affects successional changes, but overall with the kind of global weirding we've been seeing, have you seen anything notable with regard to that encroachment of those conifers?
You know, I haven't, and that's not something I've necessarily watched, but what I do know is that there's been an increase in certain non-native grasses, particularly what I think what's an interesting phenomenon is this is particularly true as you get closer to the Los Angeles basin, because there's been a lot of nutrient deposition that kind of flows out. And there's been some controversy. This is one thing that I can speak to because I've talked with Jim Andre a lot about this. But there's obviously been increases in fires across the deserts. And one argument that a lot of people are making is that with the increase of say bromus, these fires are being sort of vectored more across the landscape. But a lot of people are arguing that's not really what's the vector. The vector is how dry the plants have become, right? It's not necessarily the grass, it's everything else that's there. So, there's a lot of things that people are trying to figure out and learn right now. And I think climate change is obviously happening, but how is that being seen? I can't necessarily speak to much more than that. Dana?
The pinyon pines are actually dying at the lower levels of their habitat. So it's actually, the pinyon pines are dying the low elevations. And so you're getting the junipers are surviving, but now the pinions are dropping out.
Yeah.
And so, that's being seen over the last
at say what, 4,000 feet, 4,500 feet.
You need 8 to 10 inches for those.
Okay. Of rain. Yeah. Or snow.
Rain for those to survive.
Yeah. Okay.
And a little snowpack sometimes in the winter, I would see it come down the canyons, and that's where it stopped is where the trees stopped.
Uh-huh.
Maybe just for a few days, a week or so of snowpack.
Thanks, Dana.
Uh-huh.
Yeah.
I thought a limber pine is really unusual, fascinating. I've spent time down in the desert, never saw anything like that. I was curious to know what the average height of them.
Of a limber pine in California? Yeah, it's different in California. If you were to see a limber pine in Montana, they're going to be getting a lot bigger. But in California, they're stuck on these mountaintops, so they're almost crumholzed in many respects. So I would say 40 feet might be a big limber pine in California, maybe a little bit taller. Yeah. And they might get up to say 100 feet in Montana, where they're just living in a more hospitable environment.
Taken from the top of it.
Yes, that was at about 9,000 feet, that picture. Yeah. Yeah. Cool. Nothing else here. I can check Zoom World. Um, do we know if Native Americans planted fan palms, and is it true that they're also found along the shoreline of the Salton Sea, along the old Salton Sea? Yeah, I mean, I think it's generally believed that people for many, many thousands of years have been moving fan palms around. It's kind of the one area of the desert where they believe fire was sort of a regular piece of that environment, and that helps stimulate growth. It helps stimulate diversity under the fan palms. So yeah, I think definitely that is the case. Maggie wants to go to Saline Valley again. I like that idea. Yeah, okay, cool. Well, I think that's all the questions. So yeah, thanks for coming. Thanks for your time, and I'll hang out for a little bit and let's chat about the desert. All right.